Alright, so this is the next layer, the splash setup, the splash layer as well. Let's check what we have. This one. So this is what we want to achieve. So first as a particle, and then when it will be remeshed, so we are losing in density actually. When I compare both versions that I've done, I noticed that there is more particles on the last version. Yeah, it's a bit more, not that much, but yeah, there, for example, it's a bit more. So in the version that I've done on the Houdini 18, which is this one, if you remember, I could have more splash actually than what is already there. I don't think it's that much visible, but yeah, it would have been cool actually. Let's go back to the layer, and first we are going to emit, to create the source of the splash from the main flip simulation, which is this one. Alright, yeah, this one. Okay, good. So this is the point that I'm going to use as a source, but I don't want to emit from all of them, obviously. And I would like to specify that I just want my collider or my splash near my collider, so near the ground and near the amphora. So this is what we are going to check. And first of all, we want to remove what is not moving or almost not moving. So for example, at the end, the frame 80, yeah, this is my result, and I don't want to emit splash when it's not moving. So I'm just checking the length of the velocity and then remove the point from parameter. Then I would like to compute the distance of the particle from the particle to my collider geometry. So I want the ground and the amphora. I'm just going to use the static amphora. So if you check there, yeah, this is the out static amphora. And here, this is the ground. Alright, so I'm just computing two different attributes, the dist and the n for the normals. And I'm using the xyz dist function plus the prim uv function for the normal. Those functions are very useful. If you don't know it, you should really take a look. I'm going to use later the normal, but for now, I mean just after, I will delete and blast by the dist attribute. So let's check what we have here. And as you can see, now when it's near the ground or the ground or the amphora, then I keep it. And if it's not the case, yeah, like those one, I delete it. So this is what we get. Let's see. Yeah, something like this. All right. So now we need to take off a couple of other things. And for example, if the particle is sliding over the surface, so it means there is already a collision and then it's falling down, you know. It should be there because it's moving and it's still near the surface of the geometry, but I don't want to create splash from it because it will be not realistic. And this is why here I was computing the normal, because I want to check the velocity, I mean the dot product from the velocity and the normal, and if it is superior or greater than my angle, then I want to remove the points. So minus 0.1, because there is a minus here, should be like minus 110 degrees, something like this. I mean the angle from the velocity and the normal. And if it is superior, greater than this angle, then let's blast it. All right. So let's continue, and let's say I don't want to emit from this isolated point, neither from those big area, because it's already too crowded, let's say, and I want just something visible. So this is why I'm adding here a density attribute. So the density attribute is just a PC open there with a PC num found that I divide with the max point that I'm using for the PC open. What does it mean? It means that if here I'm looking inside a radius and I find let's say 5 points. So if I find 5 points but I can handle with the max point here like 100 points, then I find 5% of the maximum. And for example, if it was there, here I can find, for example, 100 points with a maximum of point of 100, which will be 100%. And if you scale it down from 0 to 1, I mean, if you fit it in between 0 and 1, this value should be 0.05 and this value should be 1. And this is what we are doing here. So I'm just taking the how many points that I found, then I turn it into a float value. I'm taking the maximum of the point that I'm handling with the PC open, same thing turning into float, and then divide the result. After that I export a density attribute, so this density attribute should be in between 0 and 1. 1 if I have the maximum of the point, and 0 if I don't have any points. But it will not happen because it's going to at least look for itself. So at the minimum it will be 1. And 1 divided by, I think it's 10. Yeah, 10. So the minimum value that I will get should be 0.1. Anyway, let's check that directly inside the geometry spreadsheet. And here I have the density, so 1 for the biggest, and 0.05, so the maximum of the point should be 20 actually. Maybe it's not the same that I have in the parameter. Yeah, this is 20 there. Anyway, this is really a good way to create a density attribute. And with that I can delete, for example, what is low. So up, let's see what happens if I refresh. Yeah, as you can see, all the isolated points has been removed. Alright, and I want to do the same thing for the really high density attributes. And here, as you can see, it's a bit less. It's good to me. So I can say you have my source points, fresh. Yeah, this is good. But then I need to modify the velocity, because if I take a look to them, this is falling, and I don't want that, because this is supposed to be near the collider and going on the opposite way. So I'm just modifying the velocity. Let's refresh and disable and enable, and as you can see there and there as well, the velocity is almost the opposite. And this is because I want to create like a reflection, you know, like a bounce. So how to do that? So there are a couple of vector operation to do. I would say the first one should be the normal. If you remember, we've computed the normal with the prime IV, no sorry, the prime UV function just there. So we can use it. Secondly, I'm going to use the velocity and keep it to follow the motion. And after a curl noise to add more variation, I think it's nice. And for both of them, for the previous velocity and the normal, I'm randomizing the value per pitinum to add more variation, and using the same normal length than the velocity length. So I'm using here the velocity, then multiply to the normal. Here, this is just the same thing than the random here, but the only difference is that I have added a seed to this one. And then I add everything to connect it directly to the velocity. It's quite simple, but it's efficient. Then I can handle the max velocity or the max normal value to get overall what I want. Alright, let's continue with the point replicate. So why am I doing that? I think it's in order to add more variation as well. So yeah, for example, here we have 1 point, and I don't think 1 point is very interesting. So let's replicate it and then add a couple of variation with this node. But this variation is going to be visible in the velocity. So let's see. Yeah, before it was the same and now it's a bit different. I'm using the rest here that I've created just before, and then if you check there, I copy the attribute because I want to create like a mini explosion, you know, from the center of the point replication. So at the beginning, for this point, the center was there. I'm storing this position, then I replicate the point around a radius with the shape or sphere, and then modifying the velocity by using the rest that I've computed just before, with a bit of variation as well. Alright, so what are we doing there? Okay, with array, I don't move it because it's not transformed, but here I compute the distance. So if you check there, before we got the dist attribute, and now we have the same. Actually, it's just an update, and I'm okay with that. And I'm just using, oh yeah, sorry, I was not sure actually, because it's not really needy, but I'm just make sure that if it's close to the simulated aurora, then let's decrease a bit the velocity. This is because I wanted to reduce the splash amount around this area, just to try to not hide the main motion, you know, but actually this is not really needy if you don't really need to use it. Up to you. Alright, let's continue and dive inside the simulation. Actually, this is the exact same setup that I was using for the whitewater sim. Yeah, I'm not even sure that I've changed some parameters. Let's see. It should be the same actually. Yeah, it should be the same. Okay, so nothing new and nothing special. Maybe the substeps. Yeah, the substeps is one there because I thought it was good enough. And then same thing, import, delete all what I don't need. Same thing for the group, the update for the velocity, then cache it. And this is what we have. Like this. Oh, not you. Just there. Step 5. No. Step 7. This one. So yeah, if you wanted to increase the number, the particle number, up to you, because I think it will be a bit better with a bit more particles. But yeah. So we get the same thing with the popping particles, each 20 frames. And this is what we are going to remove with the same way. So the time shift to clamp it, and the retime plus the p-scale and the sim frame attribute with the modifying p-scale here with the fraction of the sim frame, the interpolated sim frame attribute. So the exact same thing that we have done there. Here I'm moving as well the position of the particle if it's below 0. And as well, in order to not interfere with the main simulation, I've decided to move down a bit all the particles when it's colliding with the ground. Yeah, just there. So, as you can see, it's moving down just to not interfere and to keep the main simulation more obvious. Alright, same thing for those operations. VDB from particle divided by 2. I've reduced a bit the point radius scale for the same reason, to make it less obvious. This is up to you, but I think it's better. And same thing there. Nothing special. And if you remember, here, this is the version with the mesh. But yeah, just before we got something like this, and I think it was better. Yeah, more particles. Even though inside the comp, this is not really visible, so it's okay. Yeah, that's okay. All right, so let's continue.